Hello and welcome everyone to this session. I would like to introduce today our speaker, Luann Mesquita, and I will hand it off to her to introduce our topic.
Good morning to everyone in Asia Pacific, in the Middle East, and a couple of early birds in Europe. Now, this talk idea began with a very simple question. How do I chat with my graph? That's what we're going to cover today. I'm Luann Mesquita. I am CTO at CMatter, a very long time Neo4j and graph engineer. And I'm also co-author of the book, Neo4j, The Definitive Guide. Now, for this edition of Nodes, I chose to carry forward the song graph that you really see in that book. Don't worry if you haven't read it already. We're going to add some AI to it. Now, this talk should be digestible by any engineer, but in particular, if you are an enterprise JVM Java developer and you're trying to wade through, all the latest and greatest in AI every week, and you're figuring out how to get AI onto your production grade applications without sacrificing the reliability, the security, and generally the fidelity of your applications, then you are absolutely in the right place. We have 30 minutes, so I'm not going to spend an enormous amount of time on any one particular piece of the code, but you'll see it's pretty simple. I've simplified the code for demo purposes. We will get straight into it and talk about what we have, right? So we're going to start off with the graph, of course. The graph has artists, producers, albums, genres, tags. We're not going to go with songs for this particular demo. So essentially, think of the graph as your record collection. What you have on top of the graph is a regular Spring Boot application, right? It exists. We happen to be using Spring Data Neo4j, and the only thing we're going to add in at least the first part of this session is Spring AI. So what we're going to do is I'm going to take you through the journey that I experienced myself, right? So firsthand results of getting AI into your job application. And we're going to keep it simple, and we will see how far really this simplicity can take us. Now, on the right, there's a very, very simple representation of what the graph model looks like. Very few entities. In fact, the graph you see today has no more than about 200 nodes, so pretty small. And I've chosen that for a reason, to show you how you can still use AI to chat with your graph and get really good results, even with a small graph, for meaningful use cases. So we have artists, they influence each other. You have producers that produce albums, artists that record albums, tags, genres, right? Now, the methods on the left are the existing methods that we already have in our Spring Boot application. Find artists, that have been influenced by another artist, artists that collaborate with producers, so on and so forth, right? So pretty much your application. Because we're using Spring Data Neo4j, you have also access to your standard Neo4j repository methods. Yeah. Okay, now I'm going to switch very quickly to a couple of additions on this. I know it's tiny, but I just want to walk you through a few pieces. We're not going to look at all the similarity relationships for the first half of the talk. It's going to come in second. Apart from those standard methods you saw there are a couple of new ones added, mostly to deal with the semantic meaning and the stylistic influence of artists or albums. So the only addition here is a little text summary that we have on every artist and album, and we have an embedding for it. So any of the queries that you see which do a semantic match basically operate over the summaries of either the artist or the album or the producer. Okay, let's get back to the slides. So Spring AI, right? It is enterprise ready, and it's a really lightweight way to bring Gen AI into a production grade Spring application, right? Any Java Spring developer would have, zero friction to bring Spring AI in. It continues to have all the stuff you're familiar with being a Spring developer, configuration, dependency management, injection, so on. It provides a unified abstraction over various LLM providers, so that allows you to actually work with different models provided by different providers fairly seamlessly. And apart from chat, right? We're only going to focus on chat today, but apart from chat, you have all the supporting acts from Spring AI, so your vector stores and RAG pipelines and so on and so forth, memory. Okay, but we're not going to touch any of that today. So we will start with chat. And just to remind you that there are plenty of excellent talks at Nodes today, which will take you into the depths of RAG and MCP. But today, very, very simple. So what are we going to do? We are going to chat with our graph with 3 steps. The first step is we are going to inject the chat client. Now, the chat client is a Spring AI. It comes from Spring AI. We will simply inject it. It gives you a fluent API to communicate with your LLM. We're going to go with the default, so we're going to use one of the OpenAI models. We are going to provide tools that the model can use. Okay, now the tools are simply going to be a reuse of the business logic that we already have in our Spring application. We're going to annotate them, make them known to the model that there are tools that they can be used, make them available to the chat client. You don't have to set up prompt templates. I did to try and keep this demo a bit more focused, though you will actually see through the demo that I'm very likely going to be surprised by a couple of answers. But that's as well part of the learning. And then you start chatting. That's it. Okay. So before we actually get into what that chat actually looks like, I am going to switch over to some code. Okay, the main parts of the code, right? The small stuff you already know how to do. So this is our artist repository, very standard Neo4j repository. Part of Spring, when you use Spring Data, you almost typically have repositories like this. So these are existing methods that I happen to have for my working application. Added on a semantic matching cipher query, which will use really that embedding to kind of match artists by style or so on. So that remains as it is, no surprises here. Your standard Spring application properties. All I've done is extended it to include a few things, so Spring AI, so in particular my OpenAPI key. We're going to use 4.0 mini, and we're going to keep the temperature fairly low for today, again, mostly to keep this demo a bit on track. And then we get to the meat of it, which is the chat service, and literally that's it, right? So we inject our chat client. So you'll see that this comes from Spring AI. We have query tools, which I'll speak about in a minute. And once you have your chat client, because this is a command line application, user is going to type in their prompt, their query, whatever they want to say, and we are simply going to pass that on to the LLM. So we have a system prompt, which again you don't have to have, but I have had to craft this to make sure that we instruct the LLM not to use its own knowledge about the world and really stay grounded in the data and the facts that we have in the graph. So that's your system prompt. We have the tools that we're providing to it, and this is your user message. We call the chat client, get the response, return the response. Okay, that's pretty much it. Now, the tools, usually you would annotate various parts of your business logic. What I decided for the demo is I'm just going to pull them all together into a single class, so it's easier for me to walk through it without hopping all over the place. So here are examples of tools, right? If you actually look into any of them, they are just your standard. In this case, they're all actually calling the repository, right? I would typically have them up in a service somewhere. The things to note is you need to annotate your method with tool. okay, you absolutely should provide as accurate of a description as possible, because the model is actually going to try to figure out A, whether it should use your tool, and B, when it should use your tool, mostly based on this description. So you can also provide a few guardrails. You can actually provide hints as to when to use it, when not to use it, and so on. And then, of course, you have it's a standard method with parameters. And what you do is you also describe the parameters, because that's really important. The value of that parameter is really supplied by the model. Okay, so that's our tools, and we are ready to go. So let me switch back here. And I have three queries, and I'm going to go take you through each one of them in turn. Now, the first one is which artists were influenced by Pink Floyd, and they also worked with electronic producers. A fairly basic question, very nice to ask an LLM. But again, remember that this graph represents your record collection. You really don't want it to be recommending something that you've got to go out to a shop and buy your record and listen to it. So what the model should answer, and I say should because this morning it decided it would tell me something fairly different, but let's see how that goes. So you should find that we have three artists in the graph: Radiohead, Coldplay, and Tame Impala. And they were all influenced by Pink Floyd. This is true. They have worked with electronic producers, and here's where the semantic, the embedding match comes in, right? Because none of them are like directly electronic producers. Well, except the first one, but you have Kevin Parker with psychedelic pop, and you have Brian Eno with ambient, and they all come under this umbrella of electronic in some way or the other. You will see that the tools used are also very predictable, and as we would hope. In order, find me the artists that were influenced by Pink Floyd, find me producers with this semantic query, and it's actually extracted electronic producer from our prompt. And then for each of those producers, it's gone and found who are the artists that collaborated with this producer. The collaboration is actually via the album. Okay, so let's give it a go. Here we go. Okay, so that is our query, and you're going to see that the progression of tools. And I've logged the I have logged, okay, perfect demo. Okay, so let's try this again. And I'm going to make sure, I think I know what happened. Bad copy. Okay. Okay, that's better. I think I had a space that I'm not catching, or a new line. Now, as expected, the answers are fairly different. Okay, so we've got the progression of tool usage, which is correct. We have a bit of hallucination in here because I really, really do not have this particular producer in my graph. Okay, so that's very interesting. The answer is per the graph. So you have Coldplay, you have Radiohead, and you have Tame Impala. Okay, so as we progress through these queries, you're actually gonna, what I think is really valuable, it was valuable for me, and it should be valuable for you to understand that your reliance on a predictable path and a very deterministic path is not as you would expect as a traditional, enterprise developer. Okay, so here we are with this one. Let's go back. So this should have been a very straightforward question. Let's go slightly different, right? Now we're going to ask which artists combine flamenco or Latin roots with rock. to create emotionally intense performances. Now, to be able to answer this directly from the graph would require, it's not impossible, but you would have to do a fair bit of work yourself to extract which elements you want to look at, match them semantically, and come back. Now, what you get back from the LLM, hopefully, is kind of two groups of answers. They're all correct, but if you look at them a little more in depth, you'll find that there's a first set, okay, which include Triana, which include Rodrigo, y Gabriela, and Paco de Lucia, are all culturally grounded, so flamenco Latin roots, right? And you'll see that progression into rock. And then you have the second one, which actually takes the second part of our query, which is emotionally intense performances, and matches it to Linkin Park and Red Hot Chili Peppers, right? So not bad, because they aren't, they do have like very, very, very thin elements linking them together. But you can already start to see how this drift potentially happens. Now, the only tool it should use is find by semantic query, because we don't have any other information that the LLM can extract from that. So here we go. Yeah, and that is exactly the only tool it has used. Flamenco rock, emotionally intense. It chose not to put in Latin roots for whatever reason, but you can see the answer is again more or less correct, with one demo surprise, which is Prince. He does exist in the graph, but this time it happens to be returned. Now remember that this particular application has no it has no guardrails, it has no reflection, it has no evaluation, right? So you're just looking at what best can I do with a set of tools, and that's it. Okay. Now the third one we have is, I think, really exposes to me the limits now of purely working with your existing business logic and your tools. Find artists who were influenced by the Beatles and later collaborated with producers who previously worked with Pink Floyd. It's a bit of a mouthful of a question, but you can answer it with all the tools that we have provided. You absolutely can. However, the LLM just could not answer it, right? It didn't say it couldn't answer it, despite me warning it multiple times in the system prompt, but it actually came back with very plausible answers. Now, each of these, right, they are plausible, right? You have Radiohead, who had these parallels to Pink Floyd. You have Coldplay where the style slightly overlaps and so on, but none of them are factual, like absolutely none of them. And if you look at the tool chain, you will see that it starts off well, artists that were influenced by the Beatles. Producers by semantic query, yeah, okay. Now here it decided to do work with Pink Floyd. There's no way our tool is going to answer any of this, right? Based on the embeddings we have. And then it kind of like goes a bit rogue and comes back with something, finds artists who have collaborated with some producers, and there we go. So let's have a quick look. I'm actually more curious now to see if it's going to tell me something different this morning. Yeah, so it's actually picked up some of the producers who all do exist in the graph, but they do not answer the question. They are absolutely not. They're close. If you don't do any research, you would probably go away saying, okay, this is great, but it's not. Yeah. So what we've been seeing so far is we've been combining a couple of techniques. So pathfinding gives us really a very deterministic and explainable path through your graph. Right? We know this is correct. It can be a bit rigid, right? There's only so much you can do with pathfinding. Then you have queries that you can somehow compose and stack just to give you like further reach into the graph. You add some semantics over that, and you can get like richer answers, but they tend to be brittle, as you've seen over here. And so you look at this now, and when I was building this demo, my end goal was to really build a playlist. So a playlist taking me from one artist to another. So let's say the Beatles to Triana. And I want to have a progressive musical listening experience. So I want to start with an album from the Beatles, and I want to listen to it, and then I want the next album to be from another artist that is, taking me further towards my end goal. And so I progress through through that musical journey. Now with tools, just based on these observations, that the execution is unpredictable, as you saw, unfortunately, live this morning. The prompt is identical, but sometimes you have different tools triggered. Or sometimes you have like very minor phrasing changes in your prompt, and you have inconsistency in the selection. The composition can be quite shallow beyond a certain number of tools, and I have very, very few tools. The chaining logic starts to collapse a bit. So I think for the stepping stone playlist, I would be tempted to wire it up by hand, but I think it would just not survive all various conditions. Okay, so what we will do next is we're going to go into the second part of this demo. We're still staying with the JVM, we're still staying with Spring AI, but we're extending slightly into the agentic world. The purpose of the stepping stone playlist, or the flow that we're going to have, is we want to understand the intent. Who is your source? Who is your target? We want to traverse the graph to find paths between the source and the target. And we'll have a couple of candidate paths. Then we're going to actually go out to the LLM and to say, select the optimal path. Find me this path of artists that closely match the style that the user is asking for in that prompt. So you might say, okay, get me from the Beatles to Triana, but like stick with maybe a little more alt rock style, right? So we want to respect that. Then we're going to create a playlist that best represents an artist from each artist in that path, an album from each artist in that path. And then we want to do like a natural language summary of like why, what is the meaning of this journey. We're also going to extend it slightly to create a playlist from one genre to another. Now, to do this, I really don't want to change my code. That was not the goal. I wanted to simply start with identifying a genre, picking the most representative artist from that start source and target genre, and then the rest is exactly the same. Okay. What we are going to use is Embabel. This actually crossed my radar as I was preparing for the talk. It's a framework for agentic flows on the JVM, written by Rod Johnson. You should know that name if you're a Spring developer. And fairly new, but really a really great framework. So the key that I want to demonstrate today is goal-oriented action planning, right? So what it does is you specify a goal and actions to get you to that goal in some form or another. And what Embabel does is it plans for you the best route to achieve that goal. And it will replan depending on, how you're progressing and whether what they call the state of the world has actually changed in that. Now, the plans are generated using a non-LLM algorithm. So that increases, that means that you're now more testable, more deterministic. Fully type safe, you reuse your domain model, so you don't have the issue of a typo breaking your logic, which you happen to see in a lot of other frameworks. And of course, it drops perfectly well into your Spring application. So I will switch and I'm aware that 30 minutes is a very, very short for a demo, but let's do this. So the code base is the same, different organizations, I can walk through it. All you need to look at is the agent. Now this actually comes from Embabel, okay? This is my stepping stone playlist agent, and it does it should do what it says on the tin, literally. Given a source and a target, create this playlist. All we have in this class is a bunch of actions, right, that Embabel can use to get me to that goal from the user query, which is represented as a user input. So we have an action that can extract the artist. Now, this is important because we also need to figure out what to do with their genres. Since this was pretty much last minute, you have extract artists and you have extract genres with exactly a very similar method signature. The only way I could seem to force Embabel to replan and look at the genres instead of the artists was to return a null from this. I'm pretty sure there's a better way of doing it, but I'll probably learn that after this demo. So you can extract the artists, or you can extract the genres from the user input, right? Which is supplied here. And every time you get a response from an LLM, you are actually returning your domain classes. So everything is a class, right? Fully type safe. The other actions are to select an artist representative of the genre. This one actually goes out to the LLM, right? We think it has the best way to select an artist. Again, it has a tool because it needs to select an artist from those that are present in my graph. I don't want a random artist. Then we create candidate journeys. No LLM involved here, right? We're literally going to use Yen's paths, shortest paths, get a list of candidate paths between the source and the target, and we're good. The next action selects your optimal path. So we go back out to the LLM, we give it the user input, we tell it not to ignore the intent in terms of the style or the genre match that the user wants. We give it all these paths and we say, go ahead, select me the best one, right? And so it's going to respond with the path number from that list of candidate paths. Create a playlist. So from each of those albums, we are actually going to do some vector embedding math to figure out the closest album that we should match with, with this progression of artists. And then we're going to summarize and we're going to return. Okay, that's literally all the code I have to show you over here. There is nothing more to it. So we're going to go through 3 of these cases. Each of them progresses slightly more upon the other. And what I want to show you is how this gets planned. What's the sequence of operations that happen, and the result in the end. On the right, you see really some of the vector embedding logic that I use for this. So you have the chain of artists, which are the A1, A2, A3. So that Led Zeppelin, Thin Lizzy, AC/DC. Now, what we want to do is I want to find the midpoint between the vectors on either end of each for each artist, and then I want to match an album somewhere in the middle, right? Because I want to have that transition. But because I also want to have like this forward pushing musical journey, I'm actually going to weight it slightly towards the forward artist, right? So you kind of shift your space slightly forward looking, so that style should take you towards the end rather than backwards. And secondly, if there is a style very clearly in the prompt towards the album, I really want to use the album that best represents that style, because you have a lot of artists, as you know, that have maybe this one odd album, and that's the one you want, but it's not going to come up, right? Because it's going to probably pick something from the common style. So we do a bit of find that album style, and then we adjust the weight so it includes the midpoint of the artist, plus give it a little push towards the style that you want. Okay, there's, oops, I don't want to be here. I want to be in my code. So let's go very quickly, and we'll copy over one of the prompts. And when I get off this one, get into this one. Okay, so this is, again, Spring Boot application, Embabel inside. So you'll see it coming up here. The default Star Wars theme. And I'm going to get straight into it because time's going to be up soon. So that's execute this prompt. -P will actually show us the prompts as it flies by. So while it's doing its thing, let me scroll up and show you what's happened, right? So what Embabel has done is it's looked at your it's identified what the agent is, and it's tried to work out from that goal, how do I get to this goal? And it's gone through all the actions, preconditions, postconditions, what matches, what doesn't, and it's decided, okay, I have a path. Yep. It started, this is the path, so it's going to extract the artist, it's going to do the journey intent, it's going to select the path, create the playlist, explain the journey, exactly as we would expect. This was the first actual LLM prompt that it sent to extract the source and target name, which it did. Now, while this was happening, it went out to our graph, it calculated the paths, and you can see a bunch of candidate paths here that we collected, and we sent back to the LLM and said, identify the best path, right? So the LLM went and did that, and it identified exactly this path. Yep, so it's gone back, and it's now trying to summarize or rather explain that journey. I'm using GPT-5 for only the explain, Mini for the other ones. So it takes a bit of time, but you will see that we kind of went from Led Zeppelin to AC/DC through this part, and a very nice explanation, which you can actually see in a couple of places. which lay out the projection from this Led Zeppelin style blues rock all the way up to the riffs of AC/DC. Okay, I'm actually not going to run the other queries because I'm about to be booted out, but this is your plan, yep, of what happened. And if I take you back to the slides and the other three queries, which basically did more or less the same thing, you would find that the second one maps how the sound evolves from punk to alt rock. The third one is a little more complicated because the actual prompt was Elton John's melodic piano pop to Billy Joel's New York storytelling. So it's not really in your face explicit, but the LLM, well, the whole agent does a really, really good job of identifying what those albums are. So, so to summarize, here is where we are, right? We started with our graph and a Spring Boot application, and we tried to add AI to it. So the AI actually brought this interpretation to the graph and really gives you, and that reflects in the title, this harmony between the graph and your AI. So if you are a Java developer and you want to get started with AI, I really advise you to start very small, start simple, experiment with the pitfalls, just like you've seen with me. Where am I lacking? Where am I not? And then bring in, all the supporting pieces. You can bring in your RAG, you can bring in MCP, you can bring in text decipher. But I really recommend you start without all those complications, because when everything is changing around you and nothing is predictable, it's really hard to figure out which part you need to improve, right, without letting your cost run away with you. So I wish you a great Node session today, and I hope you enjoy experimenting with Spring AI and graphs.